Oh. Okay, today we are going to learn 5.5 linearization.
I thought we were doing 5.4.
So here's the formula. If f of x is differentiable at x equals some a value. If some function is differentiable at x equals a, what does that mean? It means some function has a derivative at some x equals value. X equals 2, x equals 3. Got that so far? Then, here's the formula, the linearization formula. Linearization formula, L of x equals f of a plus f prime of a times x minus a. That's called the linearization formula. So, you're going to find out that this is very easy because what does this stand for right here? The derivative, right? Doesn't that stand for the derivative? What does f of a stand for? F of x, f of s, f of x, f of a. Doesn't that stand for y? And won't the a stand for x? So, I don't know why they're doing this, but this is basically what they're teaching. Okay, they're basically teaching you this. Y minus y equals m times x minus x. If you want to get y alone, what do you usually do to this negative y1? Don't you usually bring it over to that side? Don't you usually do the distributive property and simplify everything? Mm-hmm. Isn't this really y equals m parentheses x minus x1 minus y, or plus y1, right? Yeah. So, when they show you this on the AP test, it's basically this exact same thing. What's the m stand for? Slope. Isn't that right there? Here's x1, which stands for x, plus y1. Isn't that really the y1? So isn't this the formula that we've been doing forever? But if they give it to you in this form, you'll know what it stands for then, right? And that's all we're learning today, really. That's it. So, ready to go? Part 1? Part 1.
Just move it. Just move it. There we go.
Part 1. Find the linearization. Find the linearization. Then they want you to check to see how accurate your answer is. And that's it. That's pretty much all we're doing. We're going to find the linearization and check to see how accurate it is to L of a plus 0.1, how approximate that is to the function a plus 0.1, which is something new. And I think we do 2 of these, and I got 1 other part, and we're done teaching. So, number 1. F of x equals the square root of 1 plus x. Ready to go. You need to finish these notes. Ready? If they ask you to find.
Just stop. Just stop.
Okay, ready? So, they give you the f of x function. What are you really doing in linearization? You're finding the tangent line. Aren't we finding the tangent line? So, if you don't like L of x equals f of a plus f prime of a times x minus a, don't use that. Just use the old way. Use y minus y equals m times x minus x. So, ready to go? The first thing I'm going to do, oh, we didn't do it, at x equals 0 is what we're doing. At x equals 0. Okay, here we go. So, the first thing we need to do is find the derivative of this. Why? Because that needs to go in here, right? So we have to find the derivative of that? Oh. Do you see that the square root of 1 plus x raised to the 1/2 power? So, what is the derivative of that? 1/2, 1 plus x raised to the negative 1/2 times 1, which equals 1 over 2 square root of 1 plus x, correct? Isn't this the derivative of that, right? Isn't this the derivative of that, right? I don't know, they won't be able to see what I just did, but. Okay, so, how do we find the slope? You're going to plug a 0 in there, right? What's 1 plus 0? 1 square root of 1, 1 over 2 is 1/2. So in place of m, I can put 1/2. Good? In place of x, what does x equal in this problem? 0. And how do you find the y value? Plug 0 into the original and that'll give you the y value, right? Isn't it going to be 1? So doesn't y really equal 1/2 of an x plus 1? Isn't y really equal 1/2 x plus 1? Did we find the line of the tangent line?
Yep.
Yeah. So did we really learn anything new today, linearization? No, we didn't. Yeah, if they use this formula on the AP test, you're just going to remember this formula, right? So, do we find the tangent line 1/2 x plus 1? If we graph this, it should match up. Okay, the last thing they want to do is check to see how accurate it is. All they want you to do is, your a is equal to 0. Your x and your a are exactly the same value. So, you're going to plug a 0 in. What's 0 plus 0.1? What's 0 plus 0.1? So you're going to check L at 0.1, and how close is it to the original F at 0.1 is the B part. So all you're going to do is, isn't this the linearization formula? All you're going to do is plug what in for the x? 0.1, and when you do that, you get 0.5 times 0.1 plus 1. You get 1.05. When you plug 0.1 in here, you're going to get 1.05, and you're going to see how close it is to the ridge at the exact spot at 0.1, at the f of x spot. You take the square root of 1.1, right? Which is 1.048888. Did we find the right line? Are they really, 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 really close to each other? Do we find the right line? Yes. Because the linearization graph or line is that close to the actual. We found the right slope, right? The right tangent line. Did you see what we did? So, they're going to ask you to find the linearization. After you do that, they're going to ask you how accurate it is. Your a might be 0, your a might be 3. This number might be off. If this is a 3 and this is 0.2, won't that be 3.2 or whatever the number is? When you check it, if you did this right, these numbers should be very, very, very close to each other. That way you know you did it right. Got it? Okay, part 2, are we done? Or do you want one more of these? Let's do one more. Down here. Let's do one more. F of x equals cosine of x at x equals pi over 2. We'll do one more of these. I didn't do an accuracy though. I didn't check the accuracy. I just found the linearization. But we can come up with something if you want to. Find L of x. They want you to find the tangent line, basically, right? So, isn't it, I'm not gonna use that, I'm gonna use y minus y equals m times x minus x, which is y equals, don't we have to find the formula for the slope? So, isn't the derivative of cosine of x negative sine of x? And we should be able to do this without our calculator. Isn't pi over 2 up here at 0, comma 1? What's the sign of that picture? 1. So isn't it a negative 1? So isn't the slope going to be a negative 1? Parentheses, x. Right, it's pi over 2. You see how we got that? And then, oh, I should have put this in here, but that's okay. Plus the y, right? Plus the y. And how do you get your y? By plugging what in? Cosine of pi over 2. What is the cosine of pi over 2? 0, so I don't even need that part, do I? So doesn't y really equal a negative x plus pi over 2? What is this called? Linearization. I can check it if you want me to see how accurate it is. How do you check it? F of some a value plus 0.1 to the actual linear one, a plus 0.1. What's the a value in this problem? Pi over 2. You would do pi over 2, whatever that number is on your calculator, plus the 0.1. And where would you plug that number in? Up in here. And then you would take pi over 2, add 0.1, and plug it up in here. We hope that they turn out to be exactly, very, very, very close. I'm not going to do it. If you want me to do it, I can tell you later. I just want to kind of get going on the notes. But I think we did this right. I know we did that right. So I know this will be accurate too. Good? Okay, last part. Part 2 and we're done. I always forget. Part 2. This is leading into the next chapter. Into chapter 6. Again, there isn't much to this problem, but this is remember the opposite of derivatives is integration. The rest of the year we're going to learn how to integrate, and this is leading into integration. So, if y equals f of x, if y equals f of x, and they ask you to find the derivative of that, isn't the derivative of that dy dx? What's the derivative of that? F prime of x. All they want you to do is start getting used to only having the dy on this side, because the rest of the year, the dy will only be on this side. How do you get the dx over to that side if this is in the denominator? By multiplying both sides by dx. What does dy really equal? F prime of x times dx. That's what you have to start doing in the next couple chapters. So, last problem of the day. We're done with notes. This is all they want me to do in part 2. Number 3. They give you y equals x to the 4th minus 2x. Very basic polynomial. And they tell you x equals 2 and dx equals 0.06. They're going to give you all of that. What they want you to do is two things. They want you to find dy. They don't want you to find dy dx. They want you just to find the dy part and then evaluate it. They want you to find the dy and then evaluate it by what they gave you. And that's about it. So let's just do this problem. We're going to find the derivative of this. What's the derivative of y? dy dx. Don't use y prime in this situation. They want you to use dy dx. Same thing, but they want you to use dy dx. What's the derivative of this?
4.
Minus 2. We're going to learn something new now. The last thing we're going to do is get rid of the dx by doing what to both sides? Multiplying both sides by dx. Doesn't dy really equal 4x to the 3rd minus 2? I'm going to put that in parentheses times dx. That's a. That's it. That's the a part. And what's the b part? in place of all the x's over here, I guess there's only one, you're gonna put a what? A 2, and in place of the dx, what are you gonna put there? 0.06, evaluate it. That's all they're asking you to do. What is dy equal to? 2 times 2 times 2 is 8. 8 times 4 is 32. 32 take away 2 is 30, right? 30 times what, 0.06? Not 18, 1.8. Gotta move the decimal over, so. And that's it. You do not have to do the quick review. You only have to do linearization and find dy. That's it. Linearization and find dy.
I like